Hello Year 10, for this video I've been asked to work through question 15 part C from exercise 7A of the Year 10 Cambridge 5.3 textbook. So question 15 says find the value of x correct to one decimal place in these triangles. And for part C we've got basically a large right angled triangle with a smaller right angled triangle within it. And to help unpack that, I've redrawn the two different right angled triangles that we're dealing with. So this smaller right angled triangle here that I'm highlighting in yellow, I've redrawn over here. So we see that there's a right angle, there's also an angle of 50 degrees, and we've got our unknown x as one of the sides. The other right angled triangle in this diagram is the larger one, which I'll highlight in blue. And that right angled triangle I've redrawn here. Again, we've got a unknown side of value x, which is what we need to find out. And here the other known angle is 25 degrees. So hopefully you remember from our lesson the mnemonic SOHCAHTOA, which is sine, cosine, and the tangent. And this mnemonic helps us remember which sides can help us work out which trigonometric ratios. If we start by overlaying the various labels for the sides, so in all right angled triangles, the side that's opposite the right angle we label as the hypotenuse. That will always be true no matter what the right angled triangle. Then for the other sides, the way we label it depends on the angle that we're interested in. So here we've been given the angle of 50 degrees. So the side opposite that we would label with O. In this case, that's the unknown side x. And then the side adjacent to that angle we would label with A. So I'll label that here A. For the other right angled triangle, it's the same idea. The side opposite the 25 degrees that we know, we'll label O for opposite, and then the side adjacent will label A. Now, I think the tricky part of this question is that really to work out which ratio will help us here, we need to think about the two sides that we can work with. Now, we've been given the x, which is what we need to find, but we haven't been given any other side. But what can prove useful is we can define one of the other sides. So if I let this adjacent side in the smaller right angled triangle be y, which corresponds to this part here of the original diagram, y, then the adjacent side of the larger blue triangle would effectively become y plus 10. Since we know about the 10, and we've defined the remaining part of that long side to be y. So that's how we get y plus 10. And now we can see that really we're dealing with the sides that are opposite and adjacent to the angles that we've been given in both of the triangles. So the ratio that involves both the opposite and adjacent sides is the tangent ratio. So it's the TOA part of SOHCAHTOA that's going to help us here. So as a first step, what we'll do is we will write out the equation for each of these triangles and then see if we can do something to work out the unknown value of x. So if I start with the smaller right angled triangle, we can know that the tangent of 50 degrees is equal to the opposite, in this case x, over the adjacent, in this case y. And what I'll do is if I multiply both sides by y, we'll end up with y times the tangent of 50 is equal to x. And you'll see very soon why that's a helpful thing to do. Now let's do the same thing for the larger right angled triangles. So we can know that the tangent of 25 degrees will be equal to the opposite, in this case x again, over the adjacent, and for this triangle that's y plus 10. And again, I'll multiply both sides by the denominator, so here we'll get y plus 10 times the tan of 25 is equal to x. And the reason that was helpful is now we've got x being equal to y times tangent of 50. And we also know that x is equal to y plus 10 times the tangent of 25. And if both of those things are equal to x, if y tan 50 is equal to x, and y plus 10 tan 25 is also equal to x, then they must be equal to each other. So we can conclude, therefore, that y times the tangent of 50 is equal to y plus 10 times the tangent of 25. Now the reason that will help us is if we can solve for y, and we should be able to do that, if we can solve for y here, then we can substitute that back into either of these equations, and actually if I look at them, this one's probably the simpler of the two, so we'll probably end up subbing back into this one. But if as step 1 we can solve for y, then we can substitute that back in and get our value of x. So let's do the work now to solve for y. So we know that y times the tangent of 50 is equal, and I will just expand these brackets here because that's going to help us get the y isolated. So we'll have y times the tangent of 25 plus 10 times the tangent of 25. And I'll subtract y tan 25 from both sides, so we'll have y times the tangent of 50 minus y times the tangent of 25 equals the 10 times the tangent of 25. Now, because we want to isolate the y, let's factorize it out. So we'll have y times, in brackets, the tangent of 50 minus the tangent of 25. And that will all still equal 10 times the tangent of 25. And then finally, if I divide both sides by tan 50 minus tan 25, we end up with y is equal to 10 times the tangent of 25. All divided by tan of 50 minus tan of 25. And there we have y. Now, the way these angles look, we're not going to get a nice clean whole number or even a radical here. And that's basically hinted at in the question, because if we go to the original question, we're being asked to give the value correct to one decimal place. So that's a good hint that we're going to need to punch all this into our calculator. I won't do that right away though. What I'll do is I'll substitute this back in to our equation for x, and then I'll just do all the calculator work in one go. So substituting this back in, we can now conclude that x is equal to, and instead of y times tan 50, we can write this expression for y. So we get 10 times tan of 25, all divided by tan 50 minus tan 25. So all of that represents y, and we're multiplying that by the tan of 50, and that will give us our value for x. So now at this point, let's get out our calculator and type all that in. So we're going to have a fraction, and in the numerator we will have 10 times the tangent of 25, and in the denominator we will have the tangent of 50 minus the tangent of 25, and then that whole fraction is being multiplied by the tangent of 50. And when we press equals, we do get a long decimal, so I'll just write that out. We have 7.66044, and one more 4. Oh no. 444431, and so on. And then we've been told to round to one decimal place, so the value after that first decimal place is 5 or higher, so we will round up. So we get 7.7 to one decimal place. And there you have it. That's how I've approached that question. hopefully now that you've seen that, it's something that you could replicate yourself if you had to. I think evaluating this question, probably the biggest leap is to see that we have two right-angled triangles and to have the, I guess, idea to define another unknown. So I think that's the key. Maybe that's not something you might have thought to do if you've never done a question like this before. But now that you've seen me work through this approach, hopefully you can see how doing that means you can then end up with effectively a simultaneous equation, a very simple one, that we then solve, and from there we work out y, we work out x, and it all works out quite nicely. If you do have any other ideas of how you could tackle this question differently, please let me know. Otherwise, hopefully you can see that this approach does work pretty well. You just need to be very careful with your working and make sure you don't make any mistakes as you go through all of the rearranging and effectively the algebra. Alright, hopefully you found that helpful. Tick boom.